Good morning, everyone. In the last session, we discussed about the packages information. So today we are going to discuss about the another important concept to call interfaces here. Before going to discuss about the interfaces, first we need to understand the abstract classes here. Basically, abstract classes can contain the concrete methods as well as abstract method. Same way, in the abstract classes, we can define the variables as well as we can come up with the constructors. So what are all the private method we want to define? We can define all the information inside this particular abstract classes. So let me go to the particular example what we discussed in the last session, something like abstract class here. Okay, so this is one of the abstract method we defined here, and this is the another method we defined as a concrete method. Okay, so along with this, now what I'm doing here, I'm going to define public into value is equals to something like 25. So this is the variable I'm defining, and I'm trying to use the constructor here. Getting the point? This is the constructor we are using inside this particular abstract class here. And whenever I'm trying to call this particular abstract class B, and what happens internally, where we implemented the constructor related section. Let me write the default constructor message here. Default constructor in abstract A class. Okay, and now what I will do, so the same default constructor I'm going to define inside this particular abstract class B. And now, so what you need to understand here, this is the default constructor in abstract class B. So where we implemented this information, I think inside this particular inheritance main, where is the abstract class section of code? I think, okay, so somewhere we define that. So let me go to the main class here. Here I'm going to write the one more main. Abstract AB main. Okay, so abstract AB main I'm defining. So once I define this particular abstract main, now what we need to understand here, what is the class I'm going to create here? So either you can create the abstract B or abstract A, any class you can create here. So AB is equals to new abstract B I'm creating. And finally, so AB dot, what we can do, here we can use the method called call me method as well as AB dot call me to method. And along with that, now what are the default values we are having? So if I want to print the particular value, now what we can do, AB dot value. But here, this is I'm going to print from using this. Okay, now if you observe carefully, whenever I'm trying to run here, what happens internally? So it is calling the default constructor of the particular, which class it is calling? Abstract class. Getting the point? Now what you understand here, inside this particular abstract class, we can define the constructors, variables, private method, public method. So inside the public method, we can go for the concrete method as well as we can define the abstract method. So these are all the information we can define under this particular abstract classes here. Okay, so this is important here. The abstract A class is our abstract class we define, and now what I'm doing here, abstract B is our concrete class. This is our concrete class, is nothing but it is a implementation class of this particular abstract class A, and we come up with the default constructor here, and the same thing. So we define the default constructor inside our abstract A class. So two constructors are calling. Okay, but finally, what I want to explain here, even whenever I'm trying to create an object of this particular abstract A, whenever I'm trying to create an object of this particular abstract K, so we are getting an error. Why we are getting an error? Because the abstract class is not fully implemented. It is partially implemented here. So because of the purpose of the partial implementation, we cannot create an object. But now we can able to call all the information. So we are able to access the properties, and we are able to call the two methods, and the default constructor or parameter constructor, whatever you are trying to define. So all the constructors are going to call here. Okay. So this is we need to understand. Now, so I will move on to the interfaces here. Okay. So basically, whenever we are trying to define an interface here, it is fully abstraction here. But what about the abstract classes? Abstract classes are partially abstracted here. Getting the point? But the particular interfaces are here fully abstract. We cannot define the normal method. It's like a concrete method under this particular interfaces. So whatever the method we are defining, all the methods will contain the abstract methods only here. Okay. So that I want to provide, and interfaces cannot contain any constructors here. Okay. So we can define the variable inside this particular interfaces, but the interfaces are the final here. Once it is modified, like at a first time, once the value is initialized here, we cannot modify the value. Okay. Because the behavior we already identified, the final behavior. Okay. So let's have a simple example on this particular interfaces here. So how we are going to make whatever information we are providing as a fully abstracted inside this particular interfaces here. And here what we need basically, whenever we are trying to work with the interfaces here, so here I'm going to write the interfaces line. First I'm going to write the access modifier. First I'm going to write this particular access modifier here, and interface one keyword we have, and name of the interface here. So this is the way we'll define this particular interface here. So just I'm defining the syntax here. Okay, just I'm trying to declare the syntaxes here. Okay, now observe what I'm doing here. So once we define this particular interfaces here, now we can write the methods here. The methods can contain only declarations, not the method body here. How we can write here? So return type of, if we are trying to return something, we can come up with the return type. Method name 1, and if the method is taking any parameter list here. Okay, so this is the method declaration. So this is we already identified here, and so this is the way we can come up with if we are having any methods, and along with that we can declare the variable here. So instead of declaring here, now I will write a simple example on this particular interfaces here. So let me write here only. Inside this particular, the main class is what we used, something like core Java 07. Here only I'm trying to declare the particular interfaces here. So what is the name of the interfaces I want to take? Something like callback here. The name of the interface I'm taking as a callback here, and this interface can contain one method. I'm not returning anything. The name of the method I'm going to write callback, which is expecting into param. Okay, so if we observe carefully, this is the way we are going to declare the interfaces. So now you can see access modifier I'm making public. This is the keyword we are using the interface, and the name of the interface I'm declaring as a callback, and I'm declaring the method here. If you see here, I'm not writing the public as well as abstract here. But if you observe the abstract class here, we define the abstract keyword here. Getting the point? Here we define the abstract keyword. So why we are declaring the abstract keyword? Because this abstract class can contain abstract methods, concrete method. But what about this particular interface here? So this interface can contain only abstract method. The interface cannot contain the normal methods here. Getting the point? So because of that, we are not going to write an abstract keyword here. By default, whatever the method we are writing here, this is public and abstract here. Getting the point? So by default in the interface, we are having the behavior public and abstract. So we don't want to explicitly define the public and abstract. You can write, nothing will happen here, but default behavior it's giving me the same the functionality why we need to explicitly define here. Okay, so this is we need to understand very carefully here. So once we define this particular method, now what we are going to write here. So this particular method we need to override here. It's nothing but we need to implement this particular method here. So where we can implement here. Get in the pen. So if we observe, whenever I'm trying to write this particular abstract method, what we did basically, so whenever this particular class is going to extend it to any other classes, so there we implemented this particular method. But right now, what we are doing here, we are going to implement here because it is not a class here. So this is an interface here. Getting the point. So one more keyword we are discussing here, that is called interfaces here. Sorry, implementation keyword here because of this interfaces. When we are trying to making the class to class relation, get in the bud. When we are trying to make class to class relation, what we will do, we'll go for this particular extends keyword. But right now we are not using the class. It is an interface here. So what is the keyword we are going to use? It's nothing but implements here. Okay. So let me write the implementation class here. Sorry. Let me write the implementation class here. So how we can write this particular implementation class here. Now what I'm doing here, I'm going to write this particular client here. Okay. So this is the client I'm defining. And now you can see basically it is a class here. And this particular class is going to implement callback here. Get in the point. So now observe, because callback is a interface. If it is a class, what we will do, instead of this particular implements, we'll go for the actions here. Getting the point. So class to class, we are going to use the actions keyword, and whenever we are trying to use a interface to class relation, we'll try to implement as a using this particular implements keyword. Okay. So why we are getting an error here? The client is giving me an error here. Okay. Now, so read this particular error, what happening internally. It is providing add an implement method, or you can make as a abstract class. So same thing, whatever we have seen earlier when we are trying to extend to the subclass here, if you are not interested to override the particular method, what we can do, so we can make the particular class as an abstract. Otherwise, we can implement the particular method here. Get in the point. So this is the same behavior it's providing to this particular class as well. Now what I'm doing is I'm going to implement this particular method. So now observe here. So this is the behavior of the implementation. Call back the method, and which is taking one parameter, and you can write whatever the message you want to write, like whatever the logic you want to write. So you can implement here. Getting the point. So you can implement here. So right now I'm not going to write much code here. So simply call back, call with this particular param here. Getting the point. So just I'm trying to write this particular params here. Okay. So this is important here. And along with this particular class here, now what I'm trying to understand, I'm going to provide the non-interface related methods here. So this is the one more method. It's a specific method I'm trying to write inside this particular client class here. Okay. It is a non-interface method. Getting the point. It is a non-interface method. So simply what I want to write here, so basically other method in the client class. Okay. So this is I want to provide. Mainly what we need to focus is, so this particular section code here. Getting the point. So here inside this particular callback here, we are defining only the method declaration here, and we are trying to provide the method body inside this particular client class. Now the client class is trying to implement from this particular callback here. Okay. So now what we will do, we'll create an object of this particular client and we'll call this particular two methods here. So let me comment out these two sections. Client to C1 is equals to, so client I'm object creating C1 dot, first one is call me the parameters I'm providing as a 12, and so one more method C1 dot, what is the another method we are having? It is a non-interface method. Okay, so these are all the two methods we are having here. Now what I will do, now you can see the callback method is called here, and it is a other method, the specific method we write inside this particular client class. Okay, now what we need to understand here, because so basically the interface, now what we understand, whatever the information we are writing inside this interface here, it is a fully abstract here. Getting the point? It is a fully abstract. Now what I will do, I'm going to write the constructor here. So if you write this particular constructor, what happens here? Now I'm trying to write the constructor here. Now you can see, so I will make public modifier here because we are going to call from the outside of this particular class. Now you can see what happening internally. While reading this error, we can understand here interfaces cannot have constructors here. Getting the point? Interfaces cannot have constructors. Now what you are understanding here, the interfaces we cannot create the constructor. So why we cannot create the constructor? Because interfaces cannot have the fully implementation here. Whatever we are going to write under this interfaces, all are abstract here. By default, all are public and abstract here. So in that case, we are not going to give the option to create an object for this particular interfaces here. So even we cannot define the constructor as well here. Okay, so this is I want to provide the information. So now, so just compare the abstract class and the interfaces, you'll get to understand. So what exactly the abstract class is doing here and what about the interface is doing here. Okay, so we discuss about the both information, abstract class as well as interfaces here. Okay, so any questions?
Sir, I would like to know why we are going for the interface concept, sir. What is the main purpose of the interface concept?
So basically the interface concepts here, this particular interface can implement more than one class. But here the problem, one class can extend only one class. So the hierarchy, it's going to be look like this. So if it is a super class, it's going to be extended to the one subclass here. Right. But here, if it is an interface here, so same thing. I'm going to write the callback here. And this particular callback, it can implement with the multiple classes here. So these are all the multiple subclasses here. Okay, this concept we'll call it as a multiple inheritance, and the same concept is not going to supported in our Java prospector. Okay, one type of inheritance we did not discuss at right now. So once we are familiar with the interfaces concept, we are going to discuss about the inheritance. Like we understand the simple inheritance, okay, and multi-level inheritance we already discussed here, and hierarchical inheritance we already discussed here, but multiple inheritance we did not discuss here. Getting the point? So these three we already discussed here. The multiple inheritance now we are going to discuss after the particular interfaces concept. The multiple inheritance is going to achieve with help of this particular interfaces, not from this particular classes here. Okay, so but here if you observe carefully, so the interfaces can implement by multiple classes, but can one super class can extend it to the one subclass here. Getting the point? So this is the hierarchy we are having here. If you are trying to write a comma with the one more class here, so it's not going to take here. So because of that here, we are going to provide the all information inside this particular interfaces here.
Sir, multiple inheritance means if we have two super classes and one subclass is want to have access to the two super classes, right, sir?
Yes. So that's I'm trying to, if you see here, comma with the one more class here. So for example, if it is a test class, so this is not applicable, but interfaces we can write to multiple. Okay, ignore that multiple inheritance at this point. So I will explain little bit later. But the differences between the abstract classes and interfaces. So any questions? Okay, so we'll understand the one more example here. So basically now come up with one more implementation class. This is the another client I'm trying to write here, and this particular client again, what happening internally? It's going to implement with this particular callback here. So we have one callback interfaces, and I'm going to implement this particular method here. Okay, so this is the another way of implementing the callback here. But if you see, so one callback interface now it is implementing with two classes here. First one is a client and second one is another client. Now what we will do basically here, so based on the specific classes here, based on this particular specific classes here, we are going to provide the implementation logic as a specific to the appropriate class here. Okay, so this is not the common to this particular interfaces. So this is the specific to this particular implementation what we are going to write, and this is to the another client information here. Okay, so same thing you can write here. So simply what I will do, I'm going to print this particular message here. So here I'm trying to come up with a square. I'm trying to write param multiply param. Okay, so whatever the information we are going to provide, I'm trying to multiply the values here. Let me go to this particular example. I will keep here. So this is the second object I'm trying to create. So C2 dot callback here. Now I will give as a something like a 78 here. Now if you see, whenever I'm trying to give as a 78 internally, it is trying to do the square operation here. So this is the square operation, the value we are getting here. So 6084 here, right? So this is the specific implementation we did inside this particular another client, and the callback here, just we are trying to print the whatever the value we are having. Now what you understand here, so we define the one interface here, and what are all the method we want to write. So the same method is going to reusable with the multiple classes. So there is no restrictions here. How many classes you want to implement, you can implement here. But only here, what we will do basically, we are going to override this particular callback method and we'll write the specific logic here. And if you see here, where is our main class? And here, instead of this particular client here, if I'm going to make as a callback here. Now, whenever I'm going to make as a callback, observe carefully, this particular method is not available inside the interface because it is a specific method we define under this particular client class. So this is important. Whenever you are trying to make superclass references here, first we need to check whatever the method we are having in the implementation classes, all the methods are declared in the super information. Either it is a super class or it is a super interfaces. But here, the current example, we don't have, this method is not defined inside the super interfaces here. So this is the specific method we define inside the client class. So in that case, we cannot go further this particular super references here. Okay, we cannot go for the super references. But here, we can use here. The callback I'm able to use here, and if I'm going to run the same example, the same output we are going to get. Now why we are getting the same output? Because this method is declared under this particular callback interfaces. So as I explained in the last session, at compile time, this method is going to check in the super related information if it is a super class, it's going to check in the super class, and if it is a super interface, it's going to check in the super interfaces. But at runtime, the method is going to call wherever the method is implemented here. Wherever the method is implemented. So this is very important, we need to understand here. Okay, so basically compile time is going to check with a super. Either if it is a interface or it is a class for just for declaring the purpose. So it's going to check only declaring the purpose in the super related. But runtime what happens internally? Runtime it's going to check the implementation class here. Implementation class here. Getting the pen. This is important here. So basically compile time it will check either the interfaces or not interface or class. At runtime it will go to the what is the implementation class. How it is going to identify the implementation class? So using this object here. Using this particular object it can understand the so where this method is implemented and what is an object here. So same like here also. Getting the point. So the reference is very important here because whenever you are trying to work on the logical questions, so you may understand like this kind of questions you will get here, the logical examples here. Okay. So this is all about the simple example on the interfaces here. We come up with multiple implementation classes here. And right now what I will do, so one more class I'm trying to provide here, something like incomplete. Okay, so this particular class now, again, what I will do, I'm going to implement with the same interface called callback here. So whenever I'm trying to implement again from the same callback here, now what you need to understand here, either you should implement this particular method or you can make this particular class as an abstract. Now observe, I'm making this particular class as an abstract. But here, whenever you are making the class as an abstract here, again, we can call with a what we can call it as a constructor. Now you can see this particular class can have a constructor, multiple constructor, not only the one, not only this particular one constructor. So if I want to write here, so into param, and here, now what I will do, public into, so param I'm defining. This is the param is equals to one more param here. Getting the point. So this is the way we can write the multiple constructors here. So same thing. You can define the common methods inside this particular abstract class. But only the problem here, if you are not implementing the specific method which is coming from the interface is called callback here. So then if you are not interested to implement the specific method, what we need to do, we need to make the particular class as an abstract here. Okay, this hierarchy is very important. So why I'm explaining this hierarchy, let me show you, you'll get more understand. Array list. Okay, so you can see this particular class. So this is the concrete class, basically array list here, and is extending one class here, and you can see it is implementing these many interfaces here. But if you observe carefully here, so it's not extending more than one class here. Getting the point? It is not extending more than one class. But if it observe carefully implements here, how many interface is implementing? So is having more than one interfaces here. But observe carefully. So array list is a one concrete class, is extending one abstract list. Abstract list basically it is a one of the abstract class. So again it is extending one abstract collection is a one more abstract class here. But now you can see is implementing. So whatever the class we are implementing here, so it's matching or not. Abstract class something and is implementing something here. And same thing you can see. So this is the abstract class basically and is implementing from our interface called callback. Getting the point? So the same behavior we are implementing or not, this particular class is implemented by the Sun Microsystem. But from the 1.2 version onward, this particular class is available. Which class we are discussing? Something like abstract list. But what is the behavior they are making here? So they are making the class as an abstract and they are implementing this particular interface. Why they are making the class as an abstract here? So if you see inside this list interface, so size is a method is declared here. It is not contain the method body. Getting the point? So it is a abstract method, right? Now you can see one more method, isEmpty method. IsEmpty method is also abstract method. Okay. Now observe carefully and contains method. Contains method is also abstract method because here we don't have a method body here. So where this particular methods is implemented. Okay. Now what I will do, I will copy the contains here. Now I will go to this particular class, Control O, and contains here. Now you can see, so this method is implementing or not here. Contains is contained here. So method body is open and it is closed internally. Again, one more method is calling, that is different. But here the method is implementing here. But where this method is declared here inside this particular list, because list is a interface, the implementation of this particular class is this. And why the between the abstract list is why the abstract list classes came here. And if you observe carefully here, the method is not available. Why the method is not available? Because here this particular class is not interested to implement the whatever the methods we declare inside this particular list interface here. Getting the point? So this particular class, some of the methods we implemented and some of the methods we did not implement it inside this particular class here. So whenever we are not fully implementing all the methods, so we should make the particular class as a abstract here. Okay. So same thing we are doing here. Same thing we are doing here. So we are not interested to implement whatever the method is coming from this particular callback. So that's why I'm making this particular class as a abstract here. Getting the point? So this is the one real-time example I shown here. So any questions? The abstract class and the interfaces here.
Sir, in this present class, where is which method is the abstract method, sir? Which method we are not implementing anything? Is it the incomplete method?
So it is not incomplete method. It is a constructor.
Okay.
So basically, if you are not implementing, then only we are going to make a abstract here. If you are implementing, we cannot add this keyword here.
Okay.
So for example, if I'm removing this, so this is a method, callback. This method, I'm at this point, I'm not interested to implement this. So that's the reason now what I'm doing, I'm making the class as an abstract here. Okay. So now we'll go for the nested interfaces. So how exactly we can define the nested interfaces? We already familiar with the nested classes, and we discussed about the different kind of the nested related concepts here, nested if conditions or nested loops here, nested switch cases. We already familiar with different example on the nested related, and same way, so nested interfaces here. So nested interfaces, how we can define. So this the simple example we are going to discuss here. And observe carefully to understand this particular nested interfaces here. What we will do, we'll try to write one class here. And I will go to the one more package. Inside the database, we can define the nested related concept here. And how I am defining this particular nested interfaces here, something like nested class I'm declaring first, and inside this particular class here I'm going to write the interfaces here. So public interface nested if is nothing but interface. Okay, nested interface I'm defining, and now what I'm doing is just I'm declaring the method, because inside the interface again we are not going to write the implementation of the method, right? So what is the method I'm defining? Something like so is not negative, and which is expecting one parameter, that the parameter I'm trying to make as a x here. Okay, so now observe carefully inside this particular nested class. Now I'm coming with one interface called nested interface, and the nested interface having the one method that is called is not negative. Okay, the is not negative method, it will return boolean value. So true or false it's going to return, and so this method is going to take one parameter. Okay, so how we can implement this particular method here? This is important here. How we can implement this particular method here? Okay, so how we are going to write here? Let me go for the one more class, something like nested class IMPL. So basically, this is the implementation class I'm trying to write. So this particular class I'm using implements keyword and nested interface. So if you observe carefully how this particular nested interface is coming. So this is the package we defined. So com.facebook.database.nested class. Now, so see the carefully how this particular import statement is going to give the information. This is very important here. If I'm trying to write here, so see here. So this is the same package. Getting the point. Now you can compare here the name of the package. So it is nothing but com.facebook.database. Okay, so this is same, but why this is the extra information is added here? Why it is added? Because this particular nested interface is available inside this particular nested class. So this is important. Now if you're not interested to implement this, like import this particular statement here, now what you can do, you can write this section here. Getting the point? You can write this particular section. So the path here, nested class dot nested interface. Why we are providing this particular path? Basically, the particular class, the particular interface is available under this particular class here. Under this particular class. If it is outside of this particular class, we don't need to specify any extra path here. So directly we can import this particular interface here. But because of this particular nested information, this is important. We can write like this. Otherwise, so if you are interested to import this particular only nested if interface here, so you can import up to this particular section. Okay. So I explained the two ways here. So you can write the any one of the way. So it is applicable here. So basically, we need to share the information to the compiler from where this particular the interface is loading. So that is the path we need to provide. And here, now what I'm doing is, again I'm trying to implementing the method. So what is the method I'm implementing here? It is nothing but is not negative. So default it is returning false here. Default it is returning false. Now you can see I'm going to use the ternary operator here. I'm going to use this here, the ternary operator. If this particular x is less than 0, what I will do? I will make as a false, otherwise I will make as a true. Getting the point. So this is one of the important the ternary operator related example, because in the real time, most of the time we'll try to write this particular question mark related examples, question mark related scenarios here. Okay, in the multiple locations we are going to write. So you can think here the ternary operator how much is important here. Okay, so now focus on the nested section 4. Now what we will do, we'll create an object of this particular nested class IMPL, and we'll call this particular method, and internally, so it's going to return true or false here. But most of the cases, what we need to identify, how we are going to use the nested section code here. Okay, that is important here. Now let me create an object of this particular class. Now let me remove the unwanted stuff. So here we are having, I'm going to comment out this, because instead of creating the multiple main classes, so I'm using the one class here. So NC and nc dot. So what is the method we are having is not negative, something like a 45 I'm giving. Sorry. Now I'm trying to run the same example. So what is the value we are getting? True. Okay. So this is the way we can define the nested related example here. And if you are interested to write the interface type here instead of this particular implementation class, if you are interested to write the interface type, so how we can write here? Nested if here. Nested if. Basically, we are inside the different packages here. This package is core Java 07, and whatever the classes we defined here, those are under the databases here. Now what I'm doing here, I want to import the statement here. How we can import here? So just give the control space here. It will give you the information like this. It will give you the information. So either what you can do, you can import up to the nested class. You can import this particular up to the nested class. Otherwise, so you can write like this. Okay, not, I think I imported the different import. Okay, so I imported the different package. So the same class we are already having inside the one more package. Now you can see, so this is, I'm trying to importing it. So if you are not interested to import this up to the nested interface, what you can do, you can copy this and you can type here. You can type here. So here, this is fine. Getting the point. So this is the another way of importing here. So this is the outer class I'm providing, outer class dot the nested interfaces, and it is the implementation class. So this is the way also we can write here, and we can call the same information. We'll get the whatever the expected result we are getting here, that is called true. And here what we need to understand, this is the super class reference can accessing the subclass properties here. The right side one, we are creating the subclass object only. How we are saying the subclass here? Because we are having the relation here. Getting the point? Here we are having the relation. So we are going to call this is the information as a super, and this information we'll call it as a sub. Okay. So this is the way we can write the nested interfaces here. So any questions?
Sir, in one class, can we have multiple interfaces?
Good. So if I'm going to write now, what happens here? So at this time, I'm going to write void something like now what you understand here? So we can write multiple. Basically, here the path is important because each and every interface is going to access based on this particular outer class information only. So for example here, now instead of defining this particular nested if here, now I have a one more interface, nested if 2. Now what I will do, I'm going to provide the another implementation of the method. Okay, right now we cannot use the is not negative method because we come up with different interfaces here. Getting the point. So you can write whatever the logic you are interested here. So basically you can write the each and every method. So that information basically is going to access based on this particular outer class dot nested interface. Whatever the nested interface you are going to extend here, and you can override the specific method here. Okay, so we can go for the multiple interfaces here. And what I will do in the previous example here, we discuss about the stack related example. So let me go to the stack related example where I explained here. Stack. Whatever the stack we discuss here, I think this is the stack. Now what I'm doing here I'm trying to providing the object like array type here and size and the particular index information. So these are all we are making as a private, and we have a push method as well as pop method. Now what I will do, so the same example, whatever the example we implemented in the earlier, the same example now I'm going to implement with the help of this particular interface with the implementation logic. Okay, so now observe carefully. So inside this particular database package, I'm going to write the first interface here. What is the interface I'm trying to write? Something like int stack. Okay, the int stack interface can contains here two methods here. What are all the two methods? First one, push method. The push method is expecting item and into pop method. Okay, the two method we already familiar in the earlier example we discussed here. The same information I am trying to come up with the interface with the implementation here. Okay, so this is the int stack here, and now what I'm doing here, I'm going to write the class here. So this is fixed stack, and this is the fixed stack class here, and is going to implement int stack here. And now what I'm doing here, I'm going to over declare two methods. Getting the point. So you can think here, this fixed stack is nothing but our stack class here, and this specific method we over like we come up with inside the stack class. But right now what I'm doing here, these two methods we define inside the interface. From the interface, I'm trying to override the specific two methods here. Okay. So observe carefully. Now what I will do here, I'm going to write the same information. Private. So whatever the array we declared earlier, the same array I'm trying to declare here, and one more, the TOS. So basically this TOS variable is going to play as an index role here. Getting the point? And this is important. And now what I'm doing here, I'm going to come up with a constructor. How I'm trying to creating the constructor here. So the parameterized constructor I'm providing, and dynamically I'm going to provide the size. The size also we already discussed in the previous example. Now what I'm doing here, I'm going to initialize into this particular new int here. New int. Here I'm trying to create a new array. This is important here. Getting the point? The object size, whatever the array we are providing here, the array, whenever we are calling this particular constructor, I'm providing the size here. Based on this particular size here, it's going to create an array here. For example, if I'm trying to give as a 10 here, now what happens internally? This particular int array, is going to create with 10 values. But what about the values here? The values at the time of this particular constructor, all zeros. Why it's going to initialize the zeros? The default values it's going to initialize here. Okay, so this is we need to understand here. And the TOS variable, same thing. Whatever I implemented in earlier, I'm implementing the same. Getting the point? Okay, let me copy this push method logic what we have earlier. So I'm going to write same thing. Okay, and where is the pop related example what we implemented, and this is we implemented the pop here. Okay, the same logic here. But what we need to understand here, only we need to understand this method instead of specifying inside this particular class. Now we come up with the interface here. Okay, so this is the fixed stack. Now let me go to the where we implemented the main class. I think this. Now what I'm doing here I'm going to create the fixed stack, or we can go for the int stack. Getting the point? Here we can go for the int stack. So like is is equals to new. Here we are having, this is I want to provide fixed stack here. So inside this particular fixed stack, now what I'm doing is I'm going to provide the size. So as I explained, I'm going to provide as a 10. Let me import this particular name of the class here. So once we import this name of the class, now what I'm doing is I'm going to insert this particular values. Push method. So how we can give this particular push method value? Something like I want to give multiple values, because we are trying to initialize we are trying to come up with a array here, not only one object here. So in that case, now what we need to do? So we need to use the for loop here. Int I is equals to 0, I less than, the size I'm giving as a 10. So I'm trying to give the same here. I'm trying to give the same here. I multiply 3. Okay, so this is the way we can insert the values here, and the same way I'm trying to load the values. So I will use this particular print is dot pop method I'm calling. Okay, I'm giving the some space here. I don't want to discuss much information, because the same code, whatever the code we implemented in the earlier, the same code I copy into this particular fixed stack here. Okay, now you can see this is the value I'm trying to insert into this particular fixed stack, and I print the values here. Okay, so this is the way we can go for the interfaces with the implementation class. And now what I will do, so here I'm going to provide the dynamic stack. So this is the important, whatever the example now I'm discussing, this is very important here. Why this example is very important? Basically, so before going to discuss about the dynamic stack here, where is this? Here I want to give as a 20. Getting the word? The loop I'm trying to make as a 20 here. But what is the size we are giving? 10 we are giving. How many values we can insert into this particular int array? 10 only. But this particular loops are going to repeat how many times? 20 times. Now, what happening internally? What happening internally? Now you can see all the values here. So this is the stack is full, the message is storing, or it's the message printing here. Because we come up with a printer statement here. Once the condition is satisfied, the values are printing. So only 0 to 27 is storing into this particular int array. Remaining values we are getting as a underflow. Okay, so I don't want to get this particular message. Even based on our requirement, I want to give the size bigger or smaller. For example, I given only 5 size here. Getting the point? I given initially 5 size, but I'm trying to insert 20 or 25 values. Now, in that case, I want to make the int array to dynamically. I want to increase the array dynamically. This is the one of the important. If you understand these concepts here, you can easily write any one of the custom int array related example. Okay, so observe what I'm doing here. So here only I'm going to modify the code here, and where we need to modify here. So whenever this particular condition is satisfied, instead of printing this particular message, I want to come up with a dynamic increase size. Getting the point? So dynamically the array should grow here. Whatever array we are defining is, the array should grow here. Okay, so now observe, once this particular condition is satisfied, now what I'm doing here, first I'm trying to create a one temp array. So it's nothing but the temporary array I'm creating. And what is the size I'm creating here? The size basically right now, what is the length here? What is the length we are having right now? Based on this particular length, I am trying to multiply. Now, what do you understand here? Getting the point. Now, here, what do you understand here? Basically, one more array I'm creating here. The size, basically, whatever the current length, whatever the current size we are having, so based on this particular current size, I'm trying to multiply here. Getting the point. This is important here. Based on this particular current size, I'm trying to giving the some bigger size value, and based on that, it's going to create. Into okay, let me make this. Okay, so now what you understand here, the temporary array I'm creating. So now you can see, if I'm going to give as a size as a 5, the new temporary array is going to create with a 10 size, because here we are trying to multiply with a 2. Okay, so it is a bigger size we created. So once we created here, now what we need to understand? Here we need to understand carefully. Into I is equals to 0. Why I'm trying to write this particular loop, basically stk dot length, okay, and I plus plus. So why I'm trying to write this particular loop? Because whatever the earlier values we inserted into this particular stack, initially we inserted some values into this particular stack. The stack values I want to move into this particular temp here. So now if we observe, temp of I am providing, okay, is equals to stck of this particular I. Getting the point. This is very important here. Now what you understand this particular line number 14 here? So the line number 13, we are creating one temporary new int array we are creating, and so I'm trying to store the whatever the values, because if the initially this condition will not satisfy up to whatever the length is not going to satisfy here, up to this condition is not going to satisfy, it will move on to this else section. It will insert some values here. Getting the point. Now you can imagine, if the size we given as a 5 here, up to 4, all the records are going to insert it into this particular stck. Now what I am doing here, the 4 record, whatever the 4 records are inserted into this particular stck int array, I am trying to store into this particular temp. Why I am trying to store? Because I am moving whatever the earlier stack we created, the earlier stack object into this particular temporary, and finally the temporary object again I'm going to assign into this particular the stck only. Okay, now what you understand here, the stack, whatever the stack we created, now we move all the values into this particular temporary. So once we move here, now what I'm doing here, I'm trying to assigning into same whatever the temporary we are having, again the temporary I'm assigning into this particular stack. Again I'm assigning into this particular stack here. Okay, after this I'm going to insert this particular value. So this I'm going to copy here also. This I'm going to copy here also. Okay, so this is very important, we need to understand here. Okay, now so observe carefully. We are not going to get the stack is full message from now onwards. So let's see. Here I'm giving the size as a 5, and here I'm making as a size as a 20. So carefully observe. I'm running the simple example. Now you can see, initially the size is started with the 5, but later based on this particular loop, what happens internally? All the values are inserted. All the values are inserted. How it is inserted? It's internally, it increase the array here. How it is increase the size here? We come up with the one temporary array, and all the values, the original array values we store into the temporary, and again the temporary we are storing into this particular stack. Okay, so what we will do, we'll put a breakpoint here. Okay, otherwise we'll put a breakpoint here. Okay, we'll put here only. Now I'm running the same example in the debug mode, so that you will understand how this particular dynamic array we can create. This is very important here. Now observe, so you can see item value 0. Getting the point? Here, inside this particular right side section, this right side section will give you the variable value. So this is important, we need to understand. So right now item value how much? 0. We are getting 0 here, and you can see the condition. So what is the toss we are having here? Toss we are having -1, and it's not going to satisfy the condition. L section. Okay. So one more time it is printing. Okay, this is the second time. Item is 3. Now you can see basically what is the stack we are having. Okay, up to how many values we can insert here? Getting the point? Up to how many values we can insert initially? So this is the size, initial size, this basically 0 to 4. So 0, 1, 2, 3, 4. Only 0 to 4 records we can insert because the initial size we made as a 5 here. And observe carefully. The second record we inserted, third record we are inserting. Now we'll insert the fourth record. So you can see up to the fourth record, it's move on to the else section. But whenever we are inserting fifth record, now you can see whenever we are inserting fifth record, the condition is satisfied. What is our t-base value right now? 4. And what is the length basically we are having 5. Length basically we are having 5. So why I'm making -1 here? Because size is going to start with 1 and indexes are going to start with 0. So I want to compare indexes with the length here. Indexes with the length here. So whenever we are trying to compare like this, we should make -1 here, so that the size will decrease one value. So right now the size is 4 and the index is also 4 here. So the condition is satisfied. Now what we are doing basically, we are trying to create one temp here. Now you can see this temp here. How many values we can insert here? The right side section you can see how many values we can insert here. 10 values. So you can compare here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 values we can insert. Okay, so this is the temporary new array we created and we can insert up to 10 values. Now what I am doing is using this particular loop. Now what I am doing is whatever the earlier values we are having into this particular stack. These are all the earlier values. Now I am moving into this particular temp here. Now you can see, so you can see 0 to 4. The values are moved here. So now the values, the original stack values I copied into this particular temp. So this is very important, you need to understand here. So right now, this is the STCK size and this is the temp size. Whenever this particular line number 15 is executed, so see the magic what happens here. So carefully observe, this is going to modify here. This is going to modify. Now observe. Now observe here, and earlier this is the small size of this particular STCK. Now it is a bigger one. Now it is a bigger one. So why it is a bigger one here? Because we are, whatever the temp we are having, we are initializing into this particular STCK here. Okay, now the STCK is overrid with this is the bigger size. Again, I am inserting the value. Okay, now it will go to the else condition. Again it will go to the else condition up to the 10 values. It will go to the up to the 10 values. Second else block here. Now you can see. Now again observe. What is the index value right now? It is 9. And what is the basically size? The size we are having 10 here. The size we are having 10 because initially we created only the temporary int array as a 10. Now observe what we are doing here. So what is the length we are having? 10 here. So we are going to multiply with 20. So now what you understand here? The temporary int array again it's going to create some bigger. The size we are going to provide as a 20. So now you can see the temp is creating little bit bigger here. Getting the point? Little bit is bigger. Earlier, so this much bigger it is not created. This much big it is not yet created. Okay. Now we'll copy all the values. So now you can see 0 to 9. 0 to 9, all the 10 values we inserted into this particular temporary. Now again, I'm making into this stck. Finally, we are storing here. Okay, this is the way all the values are going to insert into this particular dynamic array. Okay, this we need to understand very carefully. Now finally, these are all the values are inserted into this particular array, and we are getting the final result here. Okay, so this is the way we can make the dynamic the dynamic growth of this particular int array here. Any questions here? So any questions regarding this the fixed size and the dynamic stack related example here? Okay, so if not, I'm going to stop the session here, and we need to discuss about the variable inside this particular interface here. So once we familiar with the variable section, and now we'll move on to the default interface method. So this the concept is introduced in the 1.8. So we'll discuss the default method, how we can add, and later we'll move on to the exception handling here. Okay, so we'll continue tomorrow. Okay, if anyone, thank you.
Okay, sir. Thank you.
Thank you, sir.